Welcome in ADSUL'S Technical Campus, Faculty of Engineering and MBA. Myself, Professor Jyoti Phande. Today, in power electronics, we learn the two transistor analogy. First of all, for learning this two transistor analogy for SCR, see the structure of SCR. Here, the SCR is a four-layer structure having alternate P and N layer. These are the P and P and that is P1, N1, P2, N2. This is the structure of SCR having three terminals: anode, cathode, and third terminal gate. Now here having three junctions: junction J1, junction J2, and junction J3. Now we have to learn the two transistor analogy. It is nothing but the combination of two transistors. See, this P and P, this is the transistor number 1, say it as Q1, and NPN, this is the transistor 2 named at Q2. These are the two transistors, Q1 and Q2, means we can say that this SCR is the combination of two transistors, PNP and NPN. Now, see how it will be fabricated. Here, I will draw the structure. That is, this is the PNP transistor. First one transistor is there, P, N, and P. This P and P, that is P1, N1, P2. P1, N1, P2. This is the transistor 1. Now, the transistor 2. Here, second transistor is present. This transistor is start from N1, P2, N2. N1, P2, and N2. Now see, P1 is connected to anode terminal. Here, P1 is connected to anode terminal. After that, this N is common in between both the transistors. Also, P2 is common in both the transistors. I will connect this N1 and P2. These are common in both the transistors. After that, this N2 is connected to the cathode terminal. This is connected to the cathode terminal, and P2 is connected to the gate terminal. Here P2 is present and it is connected to the gate terminal. It is the combination of this P and P. It is the transistor 1, and NP and it is the transistor 2. In this way, this SCR is the combination of two transistors. This is the construction of two transistor analogy. Now, same diagram I will show with the help of symbolic representation. See, symbolic representation is there. This P and P, that is PNP transistor is there. Here I will draw the PNP transistor. This middle terminal is base, arrow side terminal is emitter, and remaining terminal is collector. This is the arrow is inside or inward direction, means this transistor is P and P. Here P1, this N1, middle one is N1, and remaining is P2. Here P2. This is the PNP transistor, that is transistor 1. Now I will draw the second transistor, that is Q2 transistor. This will be the second transistor, NPN. Here N, that is N1, P2, and here N2. N2 is connected to cathode, hence I will connect this terminal to cathode. Name it as collector. This will be the collector 2, base 2, then emitter 2. Okay. Now Here we can observe that this emitter 1 and this terminal is also called as an anode. This is also called as an anode. Means we can say that current flowing through this transistor or through this terminal is nothing but IE1. Current flowing through this terminal is IE1 and it is equal to IA because its terminal is also called as a anode. Now see here, say current flowing through this terminal is IE2 and it is also called as a IK. Now current flowing through this terminal is IG. Now we have to calculate the equation for anode current. See how we can calculate the anode current equation. Here anode current means output current of both the transistor. Anode current is nothing but the total current. That is anode current RA is nothing but total current flowing through transistor 1 and transistor 2. That is IA is equal to output current of transistor 1 is IC1 plus output current of transistor 2 is IC2. Now total anode current is nothing but IC1 plus IC2. Now this transistor is the common base configuration and in common base configuration current gain alpha is calculated by output current that is IC upon input current that is IE. From this equation we can calculate IC is equal to IE into alpha, that is alpha into IE. This is the equation for collector current. Now calculate the collector current equation for transistor 1 and calculate the collector current equation for transistor 2 by using this current gain equation. Then you will get IA, that is anode current, IA is equal to IC1 is nothing but alpha 1 IE1. Alpha 1 IE1 plus leakage current ICO1 plus equation for IC2 that is alpha 2 IE2 plus leakage current ICO2. This is the equation for anode current. Now we learned there that is emitter current IE1 is equal to IA and IK is equal to IE2. Put this value for IE2 and IE1. We will get the equation for anode current. IA is equal to alpha 1. IE1 is nothing but IA plus ICO1 plus alpha 2. IE2 is nothing but IK plus ICO2. Now we will get the anode current equation, but also we can observe from diagram that is IK current flowing through this cathode terminal. See in diagram, this current flowing through this cathode terminal is the addition of current coming from anode as well as current coming from gate current. Means you can calculate the cathode current. IK is nothing but the addition of anode current plus gate current. This is the addition of both the current. Now put this value instead of IK. You will get the equation for IA. IA is equal to alpha 1 IA plus ICO1 plus alpha 2 in bracket IK, put the value of IK, that is IA plus IG plus IC alpha 2 IA plus alpha 2 IG plus ICO2. Now our target is to find out the anode current. Hence take all the anode current terms left hand side and remaining terms will be at right hand side. See here, this will be the anode term equation. This will be the anode current equation. Take this on your left side. You will get equation IA minus alpha 1 IA minus alpha 2 IA is equal to, remaining terms are alpha 2 IG plus ICO1 plus ICO2. Now take the common term, that is IA is your common term. RA is the common term, you will get IA. In bracket, remaining terms are 1 minus alpha 1 minus alpha 2 is equal to alpha 2 IG plus ICO1 plus ICO2. Right? Now keep here IA, remaining term goes at denominator. You will get final equation for IA is equal to alpha 2 IG plus ICO1 plus ICO2 upon 1 minus alpha 1 minus alpha 2. This is the final equation for anode current and it is calculated from 2 transistor anode. This is the total amount of current, anode current going through the SCR. See again, equation will be alpha 2 IG plus ICO1 plus ICO2 divided by 1 minus alpha 1 minus alpha 2. Alpha 1 is the current gain of transistor 1. Alpha 2 is the current gain of transistor 2 and IG is the gate current. ICO1, ICO2 are the leakage current flowing through transistor 1 and transistor 2 respectively. Okay. Again your SCR acts as a switch. This acts as an open switch and closed switch. It will depend on the current flowing through SCR or not. These are the applications we already learned in unit 4 lecture. Okay. Thank you very much.